All right, this next formula is for giving fluid over time. And most of the time, the overwhelming majority of the time, when we give fluid over the time, it's just going to, over time, it's going to be administering normal saline. However, there are going to be times on occasion where you may have to administer a drug that is mixed into fluid, and instead of it being based on weight and how much you administer per minute, it might be how much of this drug, this total drug mixed in this little bag that you're going to administer over the course of 10 minutes, okay? So one example of that is going to be magnesium sulfate. Typically, you're going to take somewhere between 4 to 6 grams, and you're going to mix it in 100 milliliters of fluid, and then it's going to direct you to administer that fluid with the mag sulfate mixed in it over, let's say, 10 minutes. And that will be one way of administering fluid that is a drug. Most of the time, though, we're going to be giving normal saline or Ringer's lactate, lactated Ringer's, however you want to denote it. All right, so let's just talk about this one. All right, so when we give fluid over the time, we're going to use the box method again, and there's going to be just a unit of measure that's different, if you recall. So if we have our bag of saline, right, and we're going to spike it, and it's going to have that little drip chamber in it, okay, and the drip chamber is going to have like a little tube or a needle, and we're going to squeeze it so that fills up, and then of course that's going to go into our patient. Now this little tube here with the little needle-like structure is going to refer collectively along with your line as be referred to as your drop set, and it's going to be measured, and the measure is measuring the number of droplets, the number of drops to equal 1 milliliter of fluid. And when we refer to drops, we are referring to GTTS to equal 1 milliliter of fluid. So typically the drop sets are going to be either like 10 or 20 drips in a milliliter, and the lower the number, the larger the drop. And then, conversely, you're going to have 60 drop sets, and the larger the number, the smaller the droplet. Okay, so it's going to take 60 of these droplets, or 10, or possibly 20 of a droplet that's not as big as that, but bigger than that. Generally, they'll run in this range. So this is what we're going to use for fluid resuscitation in adults. This is what we'll use for fluid resuscitation in children, or to administer an infusion. Because again, the smaller drops leads to a better control of the actual dose that you're administering. All right. So since that's going to be one of the units of measure, we have to record what our drop set is, because that's going to determine how quickly we can administer a volume of fluid, right? If we use this drop set, a smaller number and larger drop set, that means we can drain through this large bag far more quickly because the drops are bigger. But they're going to drip at the same rate, regardless of how big or small. And the reason they can drip at the same rate is this little structure in here. If it looks like a tiny little needle-like projection, it's going to be the 60 drop set. If it looks like a white plastic small size straw, it's going to be the larger drop set. So this is going to be the size of our drop set goes here. So normally the total volume goes here, but the drop set size gets recorded here as either 10 or possibly 20 or 60, all right? The number here is going to be dose. So the number that goes in here is going to be equivalent to your dose. And then the number of that goes in this spot is going to be number of minutes. So it's time in minutes in this number here. And then once again, 1 goes there. So if we've been directed to give 200 milliliters of fluid over 3 hours, and we're using a 20-drop set, then we're simply going to add our numbers where they go and do the math. So our dose is 200 milliliters. Okay. Our time is 3 hours, but we do it in minutes. So that's going to be 180 minutes. We're using a 20-drop set, so it's drips per milliliter. And then 1 goes here. Now our answer is going to be in drips, GTTS, per minute. How do we cancel that out? Well, we're going to cancel out the milliliters here with the milliliters here, and what we'll end up with is drips on top of this fraction and minutes underneath, and that's how we get our unit of measure. So since we're dealing with larger numbers, let's reduce the numbers by eliminating some zeros right now. This 0 cancels out this 0. Okay? Is there anything else that we can cancel out? Well, we know that we can divide a couple of these numbers equally by each other. So we know that 2 will go into the number 18 9 times. So 18 divided by 2 is 9. 200 divided by 2 is 100. So we've made our math a little easier. So now we'll multiply across. 100 times 2 equals 200, and 9 times 1 equals 9. So now we have to reduce this further. So 200 divided by 9. We know that 9 will go into the first two numbers, 20, twice. And we've got 2 left over and another 2. And we know that 9 will go into 20 twice again. And then it would be 22.2 drops if we continued the math. Well, we're not going to round up because that's less than 0.5. So we're just going to keep the number at 22. So if we drip it at 22 drips per minute, we will give the 200 milliliters evenly spaced over 3 hours. Okay? Now to get 22 drips a minute, to be that accurate, you're going to have to use an IV pump. If you had to do it by hand, you're not going to be able to get 22 drips a minute, right? Because you might be able to get a drip a second. You could get 2 or 3 drips a second, but you're not going to be able to get, which is, 60 or 66 drips a minute, but you're not going to be able to get 22, okay? So, but you could get 20 drips a minute if you dripped it every 3 seconds, because 20 will go into 60, 60 seconds in a minute 3 times. So we could go drip, 2, 3, 4, drip, 2, 3, drip, 2, 3, 1, 2, 3. So it would be a drip every 3 seconds. Okay? So that's fluid over time.